Hello my friend and welcome to another video. Today we're gonna do another boss fight. Yeah. So in this project we have to be able to fetch a line from a file. We're gonna build up from first principles so we can really create a steel frame of understanding. So by now you know very well the write system call. This is a function that is able to print some bytes in a specific file. We usually use the file descriptor 1, which is the number of the standard output by default. So here we have write 1 hello world and 14. 14 is the number of bytes that I want to write. Hello world \n is 14 bytes because a char is 1 byte. So boom, magically we have in the standard output, which is the terminal, the string hello world. Easy peasy. You know this stuff super well. Well, here initially I didn't quite understand why the terminal is a file. I mean, isn't the terminal just a device or an application or something like that? Is it a file? Namely, we are using here a file descriptor, a number linked to a specific file. So for the system, allegedly, the terminal is just a file. Let's dig a little bit. Every time you launch a process, you have this file descriptor table that contains all the file descriptors. Basically, we have that every process has some files open for its specific purposes, right? By default, we have 3 specific files, which are standard input, standard output, and standard error. Of course, you know this stuff super well. And still, by default, these 3 files are linked to the terminal. So our process is able to take the input from the terminal and is able to write the output in the terminal itself. Everything happens inside this file, the terminal emulator. Indeed, we have in Unix and Linux systems this idea, this concept, these principles that everything is a file. I pledge you to search by yourself and dig down into this rabbit hole so you can understand better what I'm talking about, because it's fairly easy to be misunderstood. If you want a TLDR, we can say that everything behaves as a file inside a Unix Linux system. So the terminal is a file, like a file.txt, of course, is a file. This is fairly useful because allows interoperability. It means that we can interact with everything inside a Unix system or Linux with the same protocol. Again, just check by yourself. Now, as always, let's go practical for a second so we can understand, practically speaking, what I'm saying. Let's create a very basic program. I'm gonna do a put string, program running, and then I do a sleep of 100. Ask. I'm gonna compile this code, and then I'm gonna launch, okay? Prog. So the program is running, and then I'm gonna do ps in another terminal to see all the programs that are running. As you can see, I have this one, which is my program here. There, list of PID 18000, which is the PID of this process that is running. Boom. List of is showing me all the files used by a specific process. These are all library stuff, right, for the functions. And here I have my file descriptors, as you can see, which are these ones. I have 0, 1, and 2. File descriptor 0, standard input, 1 output, 2 error. And as you can see, these files are this file here, which is dev tty001. Let's copy this. First of all, let's watch what is inside that directory, /dev. Dev stands for device. So inside this directory, we have device related stuff. So if I do list all the elements, I can see that I have all these TTY. They stands for teletypers. These are the teletypers which are now open. And then I have other things that you can watch by yourself. This is basically system programming. The only thing I want to show you, here we have the permissions, and here we have the type of the file. If you search files in Unix, you will find that there are different types. For example, we have directories, they have a D as the first char. Then we have regular files, we just have an IPEN here. A symbolic link, we have an L, a socket. For the terminal, we have the C. What is this file? Well, C stands for character device, okay? So of course you can read by yourself this stuff, just to point out that these are special files, okay? Now I have 2 terminals open. If I do TTY in this terminal, I get the specific terminal I'm using. If I do the same here, I will get another terminal, you see? So now I want to show you something peculiar, maybe. I told you that in Unix and Linux systems, everything is a file. There is this concept. So if I do echo hello, I'm gonna redirect the output into this file. Okay, what is going to happen in your opinion? Enter, boom. As you can see, I get an hello in the terminal number 1001. Here, if I do the same, if I do echo hello to this terminal here, boom, I get hello in the other terminal. Basically, I am redirecting the output of echo into this specific file. It's like doing echo hello text.txt, right? And then you do cat text. You're gonna see hello, of course. It's the same idea. So given that a terminal is basically a file, let's try to do something. I want to open that file with Vim, normally, like it was a file.txt. Open. I can enter inside this character file. And now I'm gonna write inside this file. Let's watch it. I'm gonna do hello there, exclamation point, and then I'm gonna save. Boom. You see what happened? I have the content of this file, of this device file, of this character file that has been flushed, written inside the terminal. Indeed. Of course, this hello there is not gonna be saved, okay? Because this is only momentary. If I open again, nothing is gonna be seen. Basically, every time you use the write function, you say write in the standard output, you are gonna write something here. And then by default, of course, you're gonna see the output inside the specific terminal. So this long introduction just to show you that everything is a file. So as you saw from the list of commands, everything is connected to the terminal. Your standard input, output, and so on. This is done by default. Cool, let's go on. Now I want to show you how to increase the number of files open for a specific process. We can do that with the open function, right? This is gonna open indeed a file, and our process is gonna have a specific file descriptor for that file. Let's write a code. So I'm gonna delete this, and I'm gonna do int file descriptor. File descriptor is equal to open. Open takes the path of a specific file. I'm gonna do in the same path of the process, file.txt. Then I have to give some flags. For example, I want to read only. So I'm gonna do that. And if the file doesn't exist, I'm gonna do open create. So a really bare bone open function that is opening a file called file.txt if it exists, or is gonna create that file. Then it's gonna return me a file descriptor. And I'm gonna say print fd of file. Okay, I get that file descriptor of file is number 3. And if I do the same thing as before, like that, sleep 100, and I'm gonna launch in background. So as you can see, I have my process running here. I copy is pit, and I do the same thing as before. Stop pit. Now at the bottom, you can see that I have a file more, which is the file that I've just created. So basically we have this situation here in which we have in our file descriptor table another file in which I can write or read something. So now I'm gonna do something. I'm gonna say read and write. So I have the permission to write also into the file. And I do write in the standard output, hello 5. And here I do fd. You perfectly understand what is going to happen, right? Compile and launch. I have one hello that has been written in the terminal, and the other hello has been written inside the file. As easy as that. So here you have the view, right? With the write function, you can decide in which file you want to write. The terminal is considered as a file. Now I want to show you a special function which is called dup_to. It stands for duplicate. Basically, it's gonna duplicate a specific file descriptor in a specific spot in the file descriptor table. Let's try out. So in my program, I have my file, this I can eliminate, and I do dup_to of my file descriptor into 1. That by default is the standard output. In your opinion, here, watching the code, what is going to happen? I have my write 1, hello, and 5. And of course, you don't see anything in the standard output, namely in the terminal. There is something in the standard output, which is file.txt. Of course, I have the hello of before, so I can do another flag here, which is or append. Okay, in this fashion. I'm gonna recompile and launch. And this time, inside my file, I have many hellos. I've launched another time, I get 4 hellos, and so on. If I launch again, and again, and again, 3 hello more. You see? This scenario here, my friend. So the new standard output has became my file. All of this just to tell you that everything is a file, the terminal is a file is a file, and you have this file descriptor that is a series of numbers linked to a specific file that your operating system is handling when a process is launched. Cool, we can go on. For this challenge, we're going to use the read system call. The read, of course, is going to read a stream of bytes from a specific file. So it's going to exploit the same file descriptors, essentially like the write system call. So the prototype of the read function implies a file descriptor, a buffer. The buffer is an array in which you can stock the chars read. So in this case, for example, I have read from file descriptor 3 into buffer 10 bytes, 10 chars. The cool thing about the read function is that it recalls. It recalls the last position. So for example, I call one time the read function with 10 bytes in file descriptor 3. I'm going to read that 10 chars. Then when I call again the function, this is what is going to happen. Boom. I have the read cursor that is going to advance from the latest char of the previous read. So I advance indeed 10 bytes. When I call the function again the next time, boom, I'm going to advance again 10 bytes. And of course, I'm going to fetch them and I'm going to stock inside my buffer. So the read function is smart, is intelligent. It can recall the last position in a specific file with a specific file descriptor. Let's do another simple example. I have my file.txt that contains all these chars, and I want to read them with the read function. So I'm going to declare a file descriptor, then I'm going to declare a buffer with 256 bytes. Then of course I'm going to open the file. So I'm going to do open file.txt, open read only, that's fine. And here we have the permissions, but we don't care. Okay, now I do a loop. I say while. Now the read function is returning me the chars as read. So I can use that value as a Boolean value. I will stock inside a variable. I do int chars, for example, read, and I say chars read is equal to read from fd into the buffer, let's say 5 chars. Okay. All right, this is the condition. What do? Well, you just print what is inside the buffer. But first of all, you have to do something. So buffer s buffer. Here you just have to put the ending \0 to the string. So you do buffer in position chars read is equal to \0. Okay. And then you just print. Okay, let's try to launch this code and let's see the output. Okay, this output really sucks because the file is so stupid. So I'm gonna just do a lorem text and we're gonna pass. Okay, so we have a better file. And here we do like that. So we are gonna fetch every time 5 letters from this file. Okay, 5 letters per time. Let's compile and launch. You see, I have all these lines. Every line has 5 chars because that's the buffer we decided. Now, if here we do, I don't know, 25, we are gonna fetch bigger lines, of course. We're gonna get something like that, you see. Every line is gonna have more chars. So now let's get into the real problem of getting the next line of a specific file. The idea is fairly simple. The implementation, not really, but don't worry. We don't know the buffer size. We don't know which is going to be the amount of chars that are going to be read. The buffer size can be 1 or it can be 1000 or 100 million. Let's pretend we have a buffer size of 10. The idea is to stock all the strings that are read from the read system call into the heap. So we're going to read 10 chars strings and stock inside the heap into some nodes. We're going to do a linked list in the heap. This is the project in its totality. It's not that long. And now we're going to understand step by step. So we go into the header file. As you can see, I have if not defined buffer size to 10. Basically, this variable can be defined at compile time with GCC, but if it is not defined, it's going to be 10. Now, this is a node of my linked list. It's a very simple node, as you can see. I have a string and then just a pointer to the next node of the string. Pay attention here, when you create a pointer to the next element, you have to say struct slist with a name tag. You have to use the classic use of structs, because typedef has not already kicked in, right? Because first of all, you have the creation of the object, and then you have a typedef to this. Now let's go in the main file, which is getNextLine.c. As you can see, the project is fairly little. I have 3 files: header file, C file, and utils.c, in which I have some utility functions, of course. So line.c, and we go to the getNextLine function. GetNextLine is giving back, of course, a char star, namely the next line, and it's taking a file descriptor. So it has to fetch a specific string from a specific file. Here I have a pointer to my list, my linked list, to a node that I initialize with null. Here you see the static word, later I will explain, but long story short, this is a variable that behaves like a global variable with local scope. So only getNextLine can use this variable, but it recalls its value in between the calls. Difficult words, you're gonna see practically speaking what I mean. Here I want to stock, indeed, the next line I'm gonna take. Then I have my little controls. I say, hey, is the file descriptor less than 0? File descriptors can be only major than 0. Is the buffer major or equal than 0? If the buffer is 0 or less, doesn't make any sense, right, to fetch anything. And here it is just an extra control that is checking if the file can be opened. For example, if you have the permissions to open, because the read is gonna return -1 if the file cannot be opened. So I say, hey, reads inside my little buffer, which is next line, 0 bytes. So don't read anything. This is just a control to check if I can open the file. Cool. Then I have my create list function that is taking as an input my list, namely the address to the list, because I want eventually to change this value from another function. So I need a pointer to this pointer and the file descriptor. So let's jump to the create list. All right, this is the function create list. And what do we have here? We have a declaration of a variable char red that later we will understand, and then a pointer to a buffer. Then I get into a while loop. What is happening here? Well, this while loop is searching for a new line char, because we have to fetch a string till the new line included. So here there is written, search inside the list if there is a new line. And if there is not a new line, what do? You get inside the loop. Bear with me, I will explain better everything. Inside my loop, I malloc buffer size +1. Here is where I'm gonna stock my string. Of course, I have the usual control after the malloc. All the times you have to do these kind of controls. And then you call the read function. You call the read function to fd, right, which is the input, which is the file descriptor, into buffer, which is just a spot in memory in the heap. Of course, you're gonna read buffer size. Here I have to use buffer size +1 because I have to append a \0 at the end of the string. Okay, the read function is gonna return me back the number of chars read. And here I simply say, well, if the number of chars read is 0, bang char read, I'm just gonna free the buffer and I'm gonna return, because it means that I have finished the file. Even that read has returned me back a 0. Then, as I told you before, I just append a \0 at the end of the buffer, thanks to the variable char read. As you can see, char read is pretty useful. I use both as a control if the file is finished, and both as a value to append the 0. Then at the end of this iteration, I'm gonna append this string, this buffer, in the list. Then again, I'm gonna search for a new line in my list. If I don't find a new line, I keep going on stocking the strings inside the heap. Now, it's super tricky, explained through code, so we're gonna have a visual understanding. Now, here I have my file, right? And as I told you, every time I want to fetch buffer size chars and stock inside the heap, I'm gonna have buffer size 10. So I'm gonna read 10 chars. Read is gonna stock these chars inside the buffer. So we have this situation here. Of course, at the end, I'm gonna append the \0, thanks to the number of chars returned by the read function. So we have this string in the heap, okay? By now, it is not yet a linked list, but it will be. So we are here. Now I call the append function. Let's watch very briefly. The append function is going to create a new node and the last node. Last node is equal to a function that is find last node. You can very easily understand what it's doing. And the new node, of course, is going to be malloced size of type list. So I have my new node that is malloced in the heap. Of course, I have my control. And then I say if null is equal to last node, basically if my list in the get next line function is null, for example, in the first iteration, you are gonna assign at list. You see, list is a pointer to a pointer. You're gonna assign to list the value of new node. So new node that I created here is gonna become the first new node of the linked list. On the contrary, you do last node next is equal to new node. Then you're gonna assign to the new node string the buffer, of course, and you say that new node next is equal to null. So in the first case, list is equal to null. So I'm gonna change the value of list to point to the new node that I've created. So I'm gonna do that. Boom. I'm gonna make in such a way that list is pointing to the first node. The first node, of course, contains the string and a pointer initially to null, but with the loop is gonna point to the next node. So let's go on with loop, so it's gonna become easier. Now, after the append function, I'm gonna return back to my previous loop right here. And then I call again my found new line. So found new line is gonna return me back false. Of course, here we can see the find new line function that is checking for a new line and it doesn't find it. So it's gonna return false. Returning me back false here, we do again the same thing. We're gonna malloc in the heap, another string. Then we read inside this buffer another 10 chars. We're gonna do our checks, and then we're gonna append again this buffer in the list. So basically what is happening is we read other 10 chars, we check again if there is a new line, there is no new line, we keep going on with our cycle. We keep going on, other than chars, we check for a new line, nothing, and then again, until we reach a point in which we're gonna stock a string that contains a new line here, okay? So in this case, my found new line is gonna return me true at this level. So I have true reversed is gonna be false. So I exit the loop. You see what is going on with this loop? Hopefully with the animation is easy vanilla, right? I hope. So now I am in this condition. I have this linked list in the heap, and now I want to fetch the line, right? I want to fetch all the chars till n. What am I gonna do now? So I have my list created inside my get next line function. I check if the list is empty. This means that there is nothing. So I can just return null, no next line. The next important function is this one. Next line, get line. I want to get the line that is stocked inside the linked list in the heap. So let's watch the get line function. Here we are. So get line, in get line I declare a variable string len, and then I declare a pointer, which is next string. Inside here I'm gonna stock indeed the next string. Then of course I do my usual control. I do if null is equal to list, you just return null. It is redundant, but to me it's a good practice to treat all the functions like single world, all in by itself. So for me, when I'm inside the function, there is only this function that exists. So I want to be prepared for all the edge cases. So I always check for pointers if they are null, because if I dereference a null pointer, I get a segfault. So to the meat of the get line, I have string len to new line. So this is a function that takes a pointer to a list and allegedly is counting all the chars till the new line, right? Let's watch this function. This function is in utils. Here we are, len to new line. Again, I do my control. I have a variable len and I initialize to 0. Always initialize variables, otherwise you're gonna get garbage values. And then I simply loop inside the list. I say while list, of course, while list is different from null, this is totally equal. And here I say I equals 0. Of course, this is a nested while loop. I hope you know how this works. And I say while the char inside the string of the node is different from 0. Again, this is redundant, right? To write like that or to write different from 0. It's the same. What do you do? Well, first of all, you check this condition. You check if the char is the new line. If it is the new line, what do? You prefix increase the len and you return it because you want to include the new line. If this is not the new line, it is just a normal char, you increase I and you increase, of course, len. I need I and len because I'm looping inside a linked list. So every time I have to refresh my I to 0. And then, of course, I'm going to do list is equal to list next. This is going to lead me to the final node that is pointing to null. at the end, I'm going to return len. Let's watch an animation so it's going to be simpler to understand. So I have all my strings inside the nodes, inside the heap. Len to new line is just counting all the chars. So it's going to count 10 of the first string. Then it goes in the new node. It's going to count again 10. 10 plus len is equal 20. Now you understand why every time I have to refresh I, because every time I want to point to char 0 of the respective node. So it's like every time the microscope here is going to I equals 0, right? It's going to count another 10, 30, another 10, 40, another 10, 50. Then it's going to go to the last node with a backslash n, and it's going to count till n. So I get 54. I have 54 chars. So this function here is counting 54 chars. Why is it useful? Well, let's go back to the previous page. We were here, right? Len to new line. It's useful because I want to use string len, the result, 54, to do a malloc. I'm going to do a malloc, 54 in this case, plus 1 for the backslash 0. And this is going to be next string. Of course, the usual control after the malloc. And then I have another function, which is copy string. I guess you understand what is going on. It's taking a pointer to the list and next string, so a pointer to the string. Okay, here's the function copy string. As always, my friend, I have the two iterator, I and k is equal to 0, I always control for the null, and I do while at list, I again equal to 0, I say until I have a char, which is different from 0. What do? First of all, you check if the char pointed by I is equal to backslash n. In that case, you copy backslash n, and then you append backslash 0 and you return, in that case. If you don't stumble upon backslash n, you just copy the string. Very simple operation, as you can see. So you keep going on until you have a char in that specific string. Then, of course, you refresh the I and you keep going on. It's basically very similar to the previous algorithm. Here, you just go to the next node. And so we start to copy the strings. We're going to copy the string. Then we go to the other one. We're going to copy. Again, the third, the fourth, the fifth, and then we go at the bottom, we reach backslash n. So we are at this condition here, backslash n. In that case, you put in position k postfix plus plus, backslash n, and then backslash 0 in k, which is now plus 1, right, because of this postfix. So we copy and we append the 0 at the bottom. Here we are. As you can see, I have my string. I have my next line. This is exactly what I want with a function. I want to have this next line. This is accomplished with this algorithm. Now, I'm not going too deep into details because I think it's not super complicated. So we are here, we have our string back. Indeed, by the animation, it seems that I'm returning back a string, but I changed thanks to the pointer. So I changed the values of the buffer by reference. I hope you understand this point. It's pretty simple. And then I just return it. I'm gonna return this to the get next line. Here we are. So I have my next line. Now we have the last passage. We have to polish the list. We have to be prepared for the next call. So I have this function, which is polish list, that takes the address of the list. Let's watch the function, which is this one. And first of all, I'd say it's better to watch the animation. So now what I do, I have this list and I have to clean it up because the next time I want to fetch the next line. I don't need this stuff anymore. Indeed, as I told you, the list is static, so it's gonna save its state in between the calls. And now we have just to remove all these nodes. So we are gonna malloc a new node. We're gonna malloc a new node. Boom. And then we are gonna copy the chars after the backslash n from the last node, of course. So I have this cross c backslash 0. Boom. I'm gonna copy them inside the new node. Perfect. These are the chars that were fetched by the read function, but we have not used in our call to get next line, right? So we have to save them. We need for the next call to get next line. Next, I'm gonna free all these nodes. I don't need them anymore, so I'm gonna just remove all of that. Boom, I'm gonna do. And I'm gonna link list to this new node that contains the final chars that we haven't used. So now when get next line is called again, we are gonna keep on from the point we finished, which is exactly cross C. So the next time we are gonna call again the get next line, what is going to happen? First of all, we're going to check if there is a new line inside the node. No, there is not, right? So we're going to keep going on. We're going to fetch other chars with the read function. The read function is going to advance 10 chars. Then we're going to do the same. We're going to check for new line. There is no new line, so we keep going on with the loop. And I guess you understand at all what is going on. Polish is a special function that is taking care of the chars that were not used in the previous getNextLine call function. So let's watch polish. As I told you, I create a new node that I call the clean node. I search for the last node, and then I have my usual iterators and a buffer. Buffer is equal to buffer size plus 1. In this buffer, I will put the last chars of the last node, as you can see from here, right? The cross C chars. And of course, I'm going to malloc for the clean node, size of type list. Then I call find last node. This function is going to search for the last node. This is so trivial, you don't really need to check. Then what do? I want to skip all the chars before the last char, that can be 0 or new line. In our case, as you can see from the microscope, I want to start copy the chars after the new line. You see? I don't want the it dot because we have already used all of them in the previous call to get next line. So I just want cross C. This is the piece of code that is going to skip those chars. I'm going to simply increase I. Then the code here is fairly simple. You have a copy of the string inside the buffer. Here you just have to be careful about the condition because you can have files that don't have new lines, you see? You can have files that only have a terminal \0. That's why I have this condition here, but nothing super difficult, so I'm sure you understand. Then I simply assign to my string the new buffer, to the next null, and I dealloc everything. This is this part here, when I clean everything. And then I just link list to my new node, clean node, for the next iteration. So you get the gist of it, right? The main idea of the algorithm, you understand. You don't need to be bogged down into the details of the implementation. If you want to, you can check it out. This code is on GitHub if you want to check more carefully. Here you have the alloc function. It's going to dealloc all the things which are in the heap. That's all there is. Now here I have a little lorem text. We're going to test the get next line with this text. So here I have my main file descriptor. This is the line that I'm going to fetch, and this is the number of lines. I'm going to open the file read only, and then I say while line, right? The get next line is giving me back a pointer. If it's giving me back a null pointer, we are finished. You are going to print the line and the number of lines. Let's try to launch. So I'm going to compile. I'm going to compile with the utils as well. I'm going to launch. And as you can see, I have all the lines inside the lorem file. Indeed, they are the same. I have line 1, 2, 3, and 4. Now, if you want something more precise, you can go here. You can download this tester like that. You're going to clone this. In the same directory of our project, you do git clone, and you're going to clone inside this tester. So inside, we're going to make M. That stands for mandatory. So this tester is going to make all the edge cases, which are super tricky to do by yourself, right? All the possible combinations and stuff. So it's suggested to do that, in my opinion. As you can see, the the program seems to work properly with all the cases. Even when the buffer size is very, very big. Here I have 10 million buffer size, but I don't really care about the size because in the way the code is written, that's no problem. And it seems to work correctly with all the cases. So we're done, my friend. Now, the last thing I want to show you is about the static keyword. What does it mean? What a simple program. As you can see, I have my main remaining coffees, and I have this function, which is take coffee. The take coffee function is going to declare a variable with 1000. It's going to remove the coffees that are being taken, and it's going to return the value of the coffees which are in the cafeteria. And every time, the printf is going to print the number of coffees remaining in the cafeteria. Let's try to launch with a simple variable, a simple local variable. So if you launch the program, you see 999, 995, 996. The first time I take 1 coffee, the second time 5, the third time 4. Do you think it's correct? Seems like every time the number of coffees available in the cafeteria is 1000, but this cannot be true, right? We can do something like that. We can say static int cafeteria 1000. Let's try now. I'm going to run. And this time you see that the code is different. I have the first time 999, 999. Cool. But the second time already there is a change because when I take 5 coffees, these 5 coffees are going to be taken by an amount which is 999. It is not anymore 1000. This is not happening with a normal variable. At the end, of course, I have 10 coffee less than initially. So the static variable is very, very similar to a global variable like this one. Let's try to comment even this. You will see that the output is exactly the same, as you can see, but being static makes the variable accessible only to the take coffee function. That's all there is, my friend. I tried to explain in a very simple way, and all right, the video has been so long. There are many things to digest. Hopefully, I managed to make this challenge simpler, I hope. All right, that's it, my friend. Enjoy.